Alright, so what we want to do here is take a function and rewrite it so that it matches this format. So we need to have a 1 right here, and when we have a 1 right here, we'll be able to figure out what A and R are. Now R might have to be adjusted by whatever C is. So we'll have to work that in sometimes also. And then once we get it to this state, then we can rewrite it as a series using the A and the R values here. And then once we have that, we can do what we did in the last lesson and use the ratio test to determine the interval of convergence. Okay, so let's start with this one. We have that C is 0, so that kind of makes this easier. C is 0, that's fine. We already have a 1 here, so that's good. So then we know that A equals 1 and R equals 2x. And using those, we can write our sum, so series. So that's going to be 1 times R is 2x to the n power. Okay, so step 1 from our previous notes was to look at C. Step 2 was to use the ratio test. And so the ratio test off of this, we would add 1. So that would be 2x to the n plus 1 over 2x to the nth power. So if we reduce that, that's 1 degree higher than this, so we'll just be left with 2x. So that's 2x. And now step 3 is to compare that to as less than 1. Okay, so if we multiply both sides by 1/2, then we're going to have negative 1/2 and positive 1/2. So our interval of convergence will be negative 1/2 to positive 1/2. Alright. And this is a geometric series, and the absolute value of R is greater than 1. So that diverges. So we don't need to check the endpoints. Alright, now down here, it says use long division on example 1 to determine the geometric power series. Now, we could actually use this to show the geometric power series. So we could plug in a 0 right there and we would get 1. And then we could plug in a 1 there and we would get 2x. And we could plug in a 2 there, square that we would get 4x squared, etc. Okay. And I guess I should move that up so we could see some of that stuff. But at this point it says, why not use long division on example 1 to determine the geometric power series. So if we do long division on this, that's going to be a 1, and this is going to be 1 minus, so we have 1 divided by 1 minus 2x. So we can do long division there. So if we want to get rid of this, we're going to multiply by 1, so that would be 1 minus 2x, and then long division, we subtract, so those are going to cancel, and we're going to have 2x here. Now we want to cancel that with this, so we're going to multiply by 2x, that's going to give us 2x here, and minus 4x squared. And then we're going to subtract, just like we do long division with numbers. So now these will cancel, and this will be positive 4x squared. Now we want to cancel that out, so we're going to add 4x squared up top here. And that's going to be 4x squared minus 8x cubed. And that's going to be 0, and this is going to be 8x cubed. And we could continue. So we could also get the series that way. Okay. Now, this one is a bit more tricky as far as setting it up. So we need to work on this function first. So we need, over here, we need x minus 2. So in order to do that, you have to think about, well, what would that be? So x minus 2 plus 2 would still maintain the integrity of that. So our function is going to be so if we change this x to this, because we need to have the c in there, then this is going to be 6. So we're going to have 6 plus x minus 2 to accommodate the center. Now, we want a 1 here, as it said. So, in order to get a 1 there, I'm going to need to multiply 1/6 in both of these places. So now, our function is 1/6 over 1 plus 1/6 x minus 2. So the purpose of all of that was to get a 1 right here. So we had to make an adjustment here, and then that made us make an adjustment there also. So a is the numerator, so a is 1/6, and r is the opposite of that. So that's going to be negative 1/6 x minus 2. Just like r here was the opposite of that. Okay, so now, once we get it rewritten like this, then we switch it to a sum there, like we did here. So here we have the sum, and n equals 0 to infinity, and we have a times r to the n. So that's going to be I'll write it like that, to the n. Okay, so if we apply the n to that negative 1, that would be negative 1 to the n power, and then we would have x minus 2 to the n power, and then we would have 6 times 6 to the n power, so that would be 6 to the n plus 1 power. And n equals 0 to infinity. So, if we think about what we're going to get there, so that's the first thing they asked for, was the power series, geometric power series. We could write the first couple terms by plugging 0 in there. So if we plug 0 in there, we get 1, 1, and over 6. And then if we plug in a 1, that'll make this negative, and then we'll have x minus 2 over, plug a 1 in there, that's 6 squared is 36. Our next term would be positive, and etc. So r is right here. So that can just go, we can kind of bypass the ratio test there and realize that we have r here. That's what's going inside there. So we have negative 1/6 x minus 2 is less than 1. So if we multiply by 1/6, and then we would have, not multiply by 1/6, multiply by 6, we'd have 6 over here, and then if we split it up to get rid of the absolute value, we would have this. And if we add 2 to each section, we have negative 4 and 8. And so our interval is going to be negative 4 to 8 with parentheses. So all of them should be pretty much parentheses because of the geometric series. Alright, so we want to start off with a partial fraction decomposition here. So let's start with 3x minus 2 over this factors, 2x and x, 1 and 1, negative and negative. Okay, so that's going to be a over 2x minus 1 and b over x minus 1. This is a nice little review of partial fraction decomposition. So if we multiply by the common denominator, that'll cancel all that out. We'll just get that. Here, this will cancel, and so we'll have a times x minus 1. Here we'll have b times 2x minus 1. So if we let x equal 1, then that would be 1 equals, and here this would be gone, and here 2 minus, that'd be 1, that'd be b. So we would find out that b equals 1. Then if we let x equal 1/2, here we'd have 3 halves minus 4 halves, that would be negative 1/2, and then that would be 0, that would be gone. And here, 1/2, that would be negative 1/2 a. So if we multiply that by negative 2, we find out that a equals 1. So, So if we look at this, we have 1 over 2x minus 1 plus 1 over x minus 1. But if you recall from the page, we want a 1 in that first spot. So if we factor out a negative 1 here, then we can move that to the top. So that would be negative 1, and this would be, if we factored a negative 1 out of there, this would be positive 1 minus 2x. So by factoring that negative, the same thing here, if we factor out a negative 1, I'm going to write it like this, then this would be 1 minus x. Okay, so now we have a is negative 1 and r is 2x. So if we factor out that negative 1 for a, and then we have that, and then r is 2x, so we would have 2x to the n minus n equals 0 to infinity. And here we just have x, so r is x. So that's going to be a is negative 1, which is where this negative came from, and r is x, so we have that. Okay. Now, so if we rewrite this part here, that would be 2 to the n, x to the n. And if we combine these two into one, then we would have -1, and then we could factor out an x to the n here. So that would be x to the n, and then we would have 2 to the n plus 1 left. Okay, so now if we do the limit as n approaches infinity of the absolute value, okay, so we would have n plus 1. So doing the ratio test, we do n plus 1 there, the x to the n plus 1, and then 2 to the n plus 1 plus 1 over, so we would have that over 1 and times and then the reciprocal. So I'm just kind of bypassing that step. So now we just write this same thing out here. So that's n to the x, not plus 1, just the original, so just x to the n. And then right there, 2 to the n plus 1. Okay, so those negative ones cancel out, and if we focus on this, that's just going to be x, and if we focus on this at infinity, as n approaches infinity, these plus 1s aren't really going to matter. So if we focus on that, we would have 2 times 2 to the n over 2 to the n, and that will cancel at infinity. Like I said, the plus 1s won't really matter. And so we've got this down to 2x. So we've got the absolute value of 2x is less than 1. And so if we switch that up, -1, 2x, 1, divide by 2 or multiply by 1/2. So we have that. So our interval is -1/2 to +1/2. Alright, so let's try this again. We need to make some adjustments here. So we need an x minus 1 in here. So we need this to be like that. So that is going to give us an extra plus 2. So we need to get rid of that extra plus 2. So that's going to be minus 2 to balance that out. And that's still over 3. Okay. So this actually turns out to be 1, which is kind of nice. So that's going to be 3 over 1 minus this. So that tells us that a equals 3 and r equals 2 times x minus 1. So if we write the sum for that, it's a times r to the n. So that would be 2x minus 1 to the n power. Alright, so now if we use the ratio test on that, that's going to be this, where we add 1 to n. So that's 2x minus 1 to the n plus 1 over 2 times x minus 1 to the n powers. Those 3's cancel out, and then that reduces all but one of those powers. So we have 2 times x minus 1 is less than 1. And then we have negative 1, positive 1, and 1/2, multiply by 1/2. And then add 1 to both sides, add 1 to all three sections. So this will be positive 1/2, and add 1 over here, so that would be 3/2. So our interval is 1/2 to 3/2. Alright. Alright, now this is a little bit tricky. So when we look at this, we should realize, well, that's a problem because we want just a 1 here, not that whole thing squared. But if we integrated this, then hopefully you see that that might get us, add 1 to the exponent, divide by the new exponent. That might get us to where we need to be. So we're going to integrate that. So if we let u be 1 minus x, then du is going to be negative dx. And now we can switch this up. So dx, well, divide by negative 1, whatever. So that's going to be negative, and then we're going to have 1 over u squared du. Okay, so that is u to the negative 2 power. So if we add 1 to the exponent, that would be u to the negative 1, and divide by the new exponent. So divide by, we have that negative out there, and divide by negative 1. So that means that that would be 1 over, this cancels, so 1 over u, which is 1 minus x. And that is in the format we want. A equals 1, r equals x, and this has to be 1. So now we can use the fact that that is equal to the sum, n equals 0 to infinity. A was 1, and r was x. So it's ar to the n. So that looks good. Now, what's cool about that is, now if we take the derivative of this, that'll get us back to where we want it to be. And we can also take the derivative of this side. Okay, so the derivative of this we already found because we integrated that to get this. So if we take the derivative of this, we get that. So that's going to be 1 over 1 minus x squared. Just kidding. Out here. 1 minus x squared equals, and now we can take the derivative of this. They wanted the power series, so we can leave that on there. So bring the n down, and then subtract 1. So how would you know to do that trick? Well, probably if you're inexperienced, that would not be something that would come to mind, but it's about that time.